All right, let's dive deep into those fast radio bursts you sent over. These FRBs, they're pretty wild, right? Super intense radio waves, just milliseconds long. And they're coming from galaxies, like billions of light years away. It's mind-boggling. The big question is, what's causing them?
Yeah, FRBs were a total mystery for a while, but new research is helping. Telescopes like the Deep Synoptic Array, the DSA-110, it's giving us some answers.
Oh, yeah, I was reading about that. It pinpointed over 70 FRBs to their galaxies. That's a big jump, right?
Huge! It means we can study where they're coming from. Gives us clues about what's causing them.
And one thing that surprised me, FRBs are more common in these massive galaxies full of metals. What's the deal with that?
It's a clue, and it challenges some of the stuff we used to think about FRBs. You gotta remember, astronomers, when they say metals, they don't mean like iron and stuff. It's any element heavier than hydrogen or helium.
Okay.
These heavier elements are made inside stars. So older galaxies, they've had more stars live and die, they're gonna have more metals.
So these metal-rich galaxies are like the old folks of the universe, huh?
Exactly, and this is where things get really interesting. Leading theory is FRBs are caused by these crazy dense objects called magnetars.
Magnetars, man, they sound like something out of a comic book.
They do right. But they're real. They're what's left when certain stars collapse. And their magnetic fields are just insane, quadrillions of times stronger than your fridge magnet. They warp space-time.
Whoa, okay, so we got these metal-rich galaxies and crazy powerful magnetars. How are they connected?
Well, research says that what makes these metal-rich galaxies might also be good for making magnetars.
So it's not just random that we see more FRBs where there's more metal.
Right, it seems like all these metals, the heavy elements, might be part of how magnetars are born.
So how does that happen? Is it just a star dying and boom, magnetar?
It's more complicated. Most magnetars probably come from two massive stars merging. Imagine two stars, way bigger than our sun, caught in a gravitational dance.
And they smash together.
Exactly. As they get close, their magnetic fields go nuts, tons of energy. Then, bam, they merge into one giant star, supermassive, with a crazy strong magnetic field. That's how you get a magnetar.
That is wild. So these dramatic mergers are where most magnetars come from.
That's what the research says, and the connection to these metal-rich places backs it up. Remember, more metals means more stars, more chances for big stars, more chances for those stars to be in pairs, and more pairs means more mergers, more magnetars.
It's like a chain reaction. More metal, more big stars, more mergers, more magnetars. And maybe that means more FRBs.
Yeah, exactly.
But wait, if these FRBs are from billions of years ago, doesn't that tell us something about the early universe?
It does. It could mean that FRBs were even more common way back then, when galaxies were younger and, based on what we've talked about, probably had less metal.
So the universe was maybe even more active with these powerful bursts back then.
That's a really cool idea, and it's something researchers are looking into. It just shows how studying FRBs can teach us about these crazy objects and about how the universe itself has changed over time.
Okay, so we've got this connection between metal-rich galaxies, stellar mergers, maybe even more FRBs way back in the early universe. But what about the FRBs themselves? What can we learn from, like, one single burst? Is it like a fingerprint telling us about the magnetar that made it?
That's a really good question, and that's what makes FRB research so cool. Each burst, it's packed with info about where it came from. And yeah, maybe even about the magnetar itself. When we look at the radio waves, like how often they're coming, their polarization, how they change over time, we can start to see like a picture of where that burst was born.
So each FRB is like a message from billions of years ago, and we're figuring out how to read it.
Exactly. And the more FRBs we find, and the better we can pinpoint them, the more pieces of the puzzle we have.
Which is where those next-gen telescopes come in, like the DSA-2000. Thousands of antennas, way more sensitive than the DSA-110.
Oh yeah, the DSA-2000, it'll be able to see fainter FRBs, meaning we can see further back in time, and it'll pinpoint them even better, which is huge for figuring out which galaxy they're from and what's going on there.
But there's still so much we don't know, right? Like, some FRBs are one-offs, and some they repeat, almost like clockwork. Why is that?
That's one of the big ones we're trying to solve. There are a few ideas floating around. One is maybe there are different kinds of magnetars, and they each release energy differently. Some are just more prone to these repeated bursts.
So, like, some magnetars are the steady drumbeat of the universe, and others are the cymbal crashes.
Yeah. Another idea is maybe it's not just the magnetar itself, but the stuff around it. Maybe some magnetars have stuff that gets caught up in their magnetic field, and that triggers these bursts over and over.
So that's not just the magnetar, but it's cosmic neighborhood that matters.
Right, but then there's the question of, are all FRBs even coming from Magnetar?
Wait, you're saying there might be other things out there that can make these super powerful bursts?
It's possible we've learned a lot about FRBs, but it's a new field, really. We've only been studying them for like, what, 20 years? There could be crazy stuff out there we haven't even thought of yet.
Okay, that's kind of exciting and kind of scary, all at the same time. But even if it's just magnetars, there's so much we don't know. We talked to how they form, how they burst, but like, what's their whole life cycle? How long do they last? What happens to them eventually?
All good questions, and to be honest, we don't have all the answers yet. But that's what keeps this field so interesting. Always new discoveries, new theories, pushing what we know about these extreme objects.
It's pretty awe-inspiring when you talk about it. Things happening billions of light years away. These things, magnetars, they're so dense, so powerful. It breaks how we normally think about physics. And we can study them from here on Earth. That's insane.
It really is. It shows how clever humans are and how curious we are about the universe.
And the fact that we can learn so much from these tiny little bursts of radio waves, it's amazing. It's like the universe is filled with information waiting for us to decode it.
I love that. And every new discovery just leads to more questions, making us dig deeper into the mysteries of the cosmos.
So what's next for FRB research? What are the big questions scientists are working on right now?
Well, one of the big ones is, like we were talking about, the different kinds of FRBs. Why do some just happen once and others keep going? Different magnetars, something about where they are, or maybe even something totally different making these bursts. There's a lot to figure out.
Yeah, it feels like every time we learn something new about FRBs, we get like 10 more questions.
It's true. Shows how much we still don't know. But there's some cool new stuff happening. Like, we're getting better at figuring out which galaxies FRBs come from. Knowing more about those galaxies can tell us about how magnetars form and how FRBs happen.
Makes sense. And that DSA 2000, that's going to be huge for that, right? Finding more FRBs, knowing exactly where they are, that's a lot of data.
It is. With more data, we can look for patterns, connections we might have missed before. Maybe certain types of FRBs only come from certain galaxies, or even certain spots within those galaxies. That could tell us about how those galaxies changed over time, how stars live and die there, all that.
It's like each little bit of information helps us see the whole picture, not just about FRBs, but about the whole universe.
Absolutely. And it's not just about the data either. There's something really cool about how scientists are working together on FRBs all over the world, sharing what they find, coming up with new ideas, challenging each other.
Yeah, I love that about science. People from all over coming together because they're all fascinated by the same thing.
I agree. It's like even when the world feels divided, we've still got this. Curiosity about the universe, wanting to know what's out there, the excitement of discovering something new that brings people together.
Well said. This has been an amazing deep dive into FRBs, magnetars, all the mysteries. I'm definitely walking away with a whole new appreciation for the universe and for the scientists studying it.
It's been great talking about this with you. Who knows what we'll find out next? The universe is full of surprises. Can't wait to see what happens with FRBs.
Yeah, and on that note, we've come to the end of our deep dive into these mysteries. But if you're still curious, keep sending in those research papers, those articles. We're always looking for new things to explore. Until next time, keep looking up at those stars.